All right, for 3.2 worksheet, we're going to again work through some of the problems. So, number one, my directions tell me to determine whether the stated conclusion is valid based on the given information. And if not, I need to write invalid and then explain my reasoning either way. Okay, so for numbers 1 through 3, we're given this rule. If two numbers are even, then their sum is even. Okay, so that is going to be 100% true 100% of the time. That has already gone through and been proven by famous mathematicians through using different forms of reasoning, different forms of logic, different types of proofs, which we'll get into later on in this unit. So that has already been proven. We do not have to prove that. We do not have to think that that is an incorrect statement. Okay, so using this rule, we are given that the sum of two numbers is 18. Okay, so that's the scenario that we are given. The sum of two numbers is 18. Doesn't say anything else about the two numbers, just that the sum of them is 18. And then the conjecture that is made then is that the two numbers must be even. Okay, so again, my directions tell me to determine whether the stated conclusion is valid based on the given information, and if not, write invalid. So the way that we're going to prove this conjecture can be valid or invalid is we're basically going to try to think of a counterexample. Okay, so remember, counterexample means that we're basically proving the conjecture false. Okay, so that means that I do not break this thing and I do not break my given. I don't break those two, but I try to disprove this conjecture. So if my conjecture is that the two numbers that add up to be 18 must be even numbers, then the way that I can think of a counterexample to that conjecture is if I can think of two numbers that I can add together to give me 18 and they're not even. Okay? And that's exactly what I did. I know that 9 plus 9 is 18, and I know that 9 is not an even number. So because of that, I've proven this conjecture to be false because my two numbers that I used to add together to give me 18 were both odd numbers. So this conjecture has been made invalid. Okay, next up for numbers 8 and 9, we need to determine if the scenario that we are provided with, if they represent a case of deductive reasoning or inductive reasoning. Okay, so number 8. Vincent's geometry teacher told his classes at the beginning of the year that there would be a quiz every Friday. Vincent concluded that he will have a quiz this Friday. Okay? So we have to remind ourselves what is the difference between deductive reasoning and inductive reasoning. So deductive reasoning has to be based, on some kind of a fact, some kind of a rule, whether it's been explicitly stated or whether it's written down in a book. Deductive reasoning must be based on something that you can physically either have heard or physically have seen with your eyes. Inductive reasoning, however, is something that is based off some kind of an observation. It's like you witness something and then you're making a conclusion based off of what you just witnessed. Okay, so let's look at number 8. So Vincent's geometry teacher told his classes. Okay, so that's going to be the key phrase right there. His geometry teacher physically told his classes that there would be a quiz every Friday. So Vincent can conclude there will be a quiz this Friday, and that is going to be an example of using deductive reasoning. Okay, his teacher explicitly told the class that there would be a quiz every Friday. So Vincent knew what to expect Vincent knew what to expect by using deductive reasoning. Case number 9. Carla has had a quiz in chemistry every Friday for the last 2 months. She concludes that she will have a quiz on Friday. Okay, so number 9, kind of a similar situation, but the wording has been changed up a little bit. So number 9, this time it says Carla has had a quiz in chemistry every Friday. Okay, so no mention of her teacher saying there's going to be a quiz every Friday. No mention of it's like a class rule that's written down somewhere. There's going to be a quiz every single Friday. Just Carla has made an observation that every Friday that she's been in school so far, or at least for the last 2 months, there's been a quiz. And so because of that, she's going to be using inductive reasoning to make that conclusion. Because again, her teacher, it does not say anything about her teacher telling the class there's going to be a quiz every Friday. It doesn't say this written up on the board or anything like that. It just says that Carla has had a quiz in chemistry every Friday. She has noticed that she's had that quiz. So because of that, that's going to be using inductive reasoning instead of deductive reasoning. Okay, for number 11 and 12, I'm given two statements, and then I'm asked, from these two statements, is there a valid conclusion that I can draw? Okay, so let's look at number 11. So my first statement, if I lose my textbook, I will fail my math test. And then my second statement, I did not lose my textbook. Okay, so with these, the wording is going to be key. Okay, so if I lose my textbook, I will fail my math test. So I know that 100% of the time, if I lose my textbook, I'm going to fail that math test. But then my second statement, I did not lose my textbook. Now here's the thing. In the first statement, it only gave me a scenario for actually losing my textbook. If I lost it, then I was going to fail the math test. But I wasn't given a scenario of what would happen if I didn't lose my textbook. Okay, so if I didn't lose my textbook, I might still fail that math test. I maybe didn't study for it. I maybe didn't use the textbook. So because there's not any one conclusion that I am given, if I did not lose that textbook, because I could have passed the test, I could have failed the test if I didn't lose that textbook. So because there is no one conclusion that I am given from these two statements, I'm merely going to put there's no valid conclusion that I can write. There's no valid conclusion that I can come to. Okay, number 12. If it is sunny tomorrow, I'll go swimming. And if I go swimming, I'll miss the baseball game. Okay, so with this time I do have a valid conclusion that I can pull because I've got the same statement that appears in both of the sentences. Okay, so if it is sunny tomorrow, I'll go swimming, and then if I go swimming, I'll miss the baseball game. So basically, this is kind of resembling a chain of events. Okay, and if I take out that middle man, I can make my new statement. I can make my valid conclusion. So if it is sunny tomorrow, I'll go swimming. If I go swimming, I'll miss the baseball game. Take out the middle man. And so if it is sunny tomorrow, eventually I'm going to miss the baseball game. Now, yeah, I'm going to miss the baseball game because I went swimming, but that's all I'm doing here is I'm just cutting out the middle man. If it is sunny tomorrow, I'll miss the baseball game.